Hello, welcome back, everybody. Hi, Dawn. So plot twist, we've changed the schedule around a little bit. So we're going to go with Don Mowry first, and then Nathan Fennell will come on after him. Don, did you want to say anything before we start your talk?
Yeah, sure. So I'm a developer at Rosetta Stone, and last year we switched over from using Appium 4 and Nightwatch for automating our UI test to just the XCUITests platform using for automating our UI test. And so this is a pattern that I found was really helpful, and so I wanted to share it. And that's it.
Great. And as always, if you have any questions for Don, you can join his channel where we will take care of your questions at the end of the talk. Thanks so much. Let's get started.
This is how I improve my testing life, by letting a screen robot test my UI for me. Like all developers, I know that regular testing helps keep my app healthy and supports confident refactoring. Unit tests can test the business logic of my app, but automated UI tests can make sure that the app is behaving correctly from the viewpoint of the person using the app. By automating these tests, we can ensure repeatability and free up testing time to be spent on things that are more difficult to test, like integration or things that require human verification. On iOS, we use the XCUI framework to perform these tests, but UI tests can be longer and more complicated than writing unit tests. Writing raw XCUI tests can lead to code that's repetitive, unintuitive, fiddly, full of timeouts. A robot is going to help us with this. Not this robot, rather a screen robot. Jake Wharton of Square gave a talk at a Kotlin night describing screen robots, essentially a page object for Android apps for UI tests with Espresso. By adapting the concept to iOS, we're reaping the same benefits. The key concept in screen robots is separating the what of what you're testing from the how of how you'll go about testing it. What we want to test should not be buried in how we go about testing it. To demonstrate, I'm going to be testing the interface of a very simple app. This is a flashcard app meant to help you study Gaelic. You can see there's a list of topics, and selecting one leads to a screen full of cards. We can flip them over and flip them back. We can scroll down and see how to say vegetables in Gaelic, glashray. Let's design a simple test for this UI. We're going to go to the topic list, select a topic, flip a card, flip it back, and then go back to the topic list. This is the what of what we want to test. Here we see the XCUItest of the how. What we want to test is obscured by the detail of how XCUItest goes about it. Let's look at this in Xcode. When we start a test, we want to launch the application. XCUItests run a separate process and don't have access to the internals of the application, unlike unit tests that can use testable import. Then, we'll want to make sure that we're on the screen that we expect to be on. We give it an identifier to the view that we are testing, and we'll reference it here. Next, we'll want to select a cell from our topic list, and we want to do it through a string that is not going to change through localization. We want to make sure that the front of the card is tappable, and that the back is not. You'll notice here that in spite of what I said earlier, the ID that we use is actually the term. This is fine because this will not be localized. Details like this depend on your data model. We tap the card to flip it, just like a user would. We want to give time for the animation to finish, and so we set up an expectation here and wait for it. Then we want to assure that the card is flipped over. Finally, we navigate back and make sure that the screen we expect to be on is once again visible. Let's run it. It's always fun to sit back and watch your app being run automatically. We select a topic, flip a card, and navigate back. At its core, a screen robot is a plain old Swift object that imports XCTest. When I first started developing screen robots, I would inherit from XCTest case. But that would cause our test robots to show up in the test plans, which is not what we want. Here we give access to the application through a simple variable, and we have a view name. This will be overridden in the subclasses. When we start our screen robot, we want to call app.activate. This is going to launch the app if it's not running, or switch to it if it already is. A screen robot gathers up common elements. You can see that in tab here. When we tap on an element, we want to wait to make sure that it's hittable before we do it. Otherwise, we could run into random intermittent failures due to timing errors, animations, networking, etc. Keeping this here is going to make our test more stable. Also, we may want to tap on an element only if it's there, maybe to dismiss a pop-up or some other transient object. But it's not a failure if it doesn't exist. When we want to interact with a text field, we want to make sure that the keyboard, the software keyboard, is up and ready. We actually need it to be on screen, otherwise our text entry won't work. Rather than scatter that logic through a test, we can keep it here. Earlier, I had pointed out that we want to ensure that we are on the right screen, and we do that here. Waiting for activity indicators to disappear is also a common function, so that goes here. XCUIElement, the class that represents the objects that we interact with on the screen, can use some new abilities as well. To delete all text, say from a login field, we're going to want to double tap the text to select it, and then we can type the backspace character. We can wait for objects to appear or disappear on our screen, or we could perform a closure if they do exist. Now you'll notice that most of these functions return self, and whether the caller cares or not is unimportant, so it's a discardable result. This is a commonality in these robots and will help us later on. Now that we have a class with common abilities, we're going to extend it for every screen in our app. Our app is small and we have 2 screens. The topic list robot overrides the screen name here. This allows us to use the function that we saw earlier to ensure that this screen exists. We have a list of the elements that are on the screen that we're going to want to interact with. This is a small screen, has one table view, so we list that here in a private lazy var. And here is where screen robots really start to shine. What do we want to do on the screen? We want to select the topic. We'll make sure we're on the screen and that the table view is there. We'll select the specified cell. Notice that if this cell is not on the screen, this will fail. This is what we want. We want failures to be contained within the screen robots themselves. Selecting a topic should be possible, and if not, then this whole function will fail. We know what happens next in this app. The card list screen appears, and so we're going to declare that here. We're going to declare that the screen actually is on view, and we're going to return that robot. Let's take a look at that screen robot. Here, this screen too has an identifiable view. Now, what are the things that we're going to want to do on the screen? We're going to want to flip over a card. We're going to see this as similar logic to what we saw before in their bare UI test, with the added ability of indicating whether a card is face up or face down. If we go to test that we can flip cards over, but they're already over, that's a failure. Like before, we're going to want to declare that we're on this screen. We're going to want to see which we expect the top face and the bottom face element, and which one we expect to be currently face up and face down. Then we can assert that the ones that are hittable should be hittable, and the ones that we expect not to be are not. We tap the card like before, we wait for it to flip over, and we assert our conditions. We know that when we navigate back, we're going to be back to the card topic list, so we declare that here. Navigation in your app can be complicated, and gathering all that logic within the screen robot makes sense. Now that we have the screen robots defined, let's use them. We'll go back to the test and add a new test case.
All of the complexity about selecting, verifying, assuring, asserting, that's all contained within the robots themselves. The test itself now reads almost like English. On the card topic screen, select a topic, flip the specified card, flip it back, and tap back.
In fact, this is the what of what we want to test. And here's the final test. The verbs and nouns are practically the same, and what this test does is clear. Just like when developers write code, they verify that logic with unit tests. So too when they write UI, they create a screen robot. They list the elements on a screen in lazy private vars and create functions that describe how people interact with the screens. By describing through functions how the app is used, they make tests easy to write. A tester can use that incredible QA mindset to write tests to interact with the screen, test edge cases, extreme inputs, and so on. They don't have to do that manually, and they can build up a library of tests that can be run in any order. One thing that hasn't been apparent so far is that our app is actually written using two different UI paradigms. The first screen, the table view, is written in the pure UI kit that we all know and love, and the second screen with the cards is written in the new fave, Swift UI. To the person tapping on the screen, UI is just UI, and so too to XCUITests, this is just UI. Swift UI makes accessibility labels and identifiers available to us. Throughout our tests, we've been using accessibility identifiers to interact with the elements on our screen. The screen robots need to know which element they're interacting with, and identifiers are the way that they do this. You could also do this by queries, walking down the UI hierarchy, or using things like first match. But identifiers are going to be stable and more reliable. While assuring that every element is identifiable, that would be a great time to make sure that every element in your application is also accessible using accessibility labels and hints. In fact, Apple provides us with a great tool to ensure this accessibility identifier. We can also leverage this to get identifiers and make sure they are what we expect when we're writing our robots. This is the first of a few tips that I want to share that helped us as we build out tests. Something I ran into while writing a test that entered text into a text field was that if the on-screen software keyboard was not up, text entry did not actually work. The simplest fix for this was to disconnect the hardware keyboard in the simulator. However, this isn't scalable across machines and simulators on my box, the CI box, etc. One workaround is to add a script in the pre-actions of the test action of the scheme. This will make sure that the simulator runs fresh and reads the plist value and tells the simulator to use the software keyboard. Sometimes you want to share some information from your test to your running app, such as the conditions that it's running in. Doing this isn't as simple because your app is actually running in a different process. One way to do this, though, is through launch arguments. Before launching the app, you can pass arguments. Since screen robots use .activate instead of .launch, you can make sure that the app is running in a test before using a robot. Then, in the main app, you can read those arguments using either command line arguments or processinfo.processinfo.arguments. Wrap this in a debug preprocessor conditional to protect your app. Test plans were a great addition to Xcode. You can group your tests together into, say, a smoke test to make sure a build succeeded correctly, or a full regression test when you're about to release an app. Test plans can be run in parallel, which is really cool to watch as three simulators exercise different tests. This can be run from Xcode or from a shell, for instance on a CI box. They record failures and take screenshots. And you can use launch arguments here as well, along with other options. I encourage you to check out test plans if you haven't. Also, sometimes you need to capture application state to track down a tricky bug or to get your test to launch in a specified condition. You can use the Devices and Simulator window to grab a container off of a device and then use that .xeAppData bundle in your test plan or ad hoc when running the app. When you change things in your app, you want your UI test to fail. One of the things that could change is the identifier that you're using to label your elements. This is probably important and what we want, but another way to make sure that they stay consistent is to explicitly name them with enums. We could use a struct to provide a kind of namespace. Accessibility identifiers is the namespace. Then we can extend it for each screen in our app. Using enums, we could list the elements to be identified. Then we can share this file between targets. In our view controller, we replace our string. We can then replace it in our test. Now that screen robots have entered my developer life, writing UI tests is much more satisfying. I love writing literate tests and sitting back and watching the app do the work and let screen robots test my UI.
All right. Sorry for the technical glitch. I was rendering or transcoding one of our videos, and apparently there is a limit to the things that my computer can do at the same time. But minor glitch, and we got it taken care of. So thanks, Don, for doing that. We do have some questions, I believe. I'll go backwards just because that's where I'm at right now. So if you use a launch argument in a test plan, you don't have to add it programmatically in the actual test case?
That's right. So, but it would apply to every test in that test plan. So you could have a bunch of, a lot of more granular test plans. The way we've done it, we kind of have more high-level test plans. So, like, we'll have a smoke test and a full regression test, and I think we have 3 test plans. But we also have a launch argument that tells the application that it's being tested in a UI test, and so we'll do some things like we allow it to log people out automatically in a way that wouldn't be possible normally. So. Yeah, in general, the launch arguments that we have been using are applicable to a whole test plan. But you could get more granular with the test plans.
Oh, gotcha. Okay.
And also within the test itself, if you wanted to, if you start had a setup in the test itself with the launch argument, then when you instantiate the screen robot, since we're using .activate, it's going to use the application that's running that's been launched with that launch argument.
Gotcha. Excuse me. We got one more. In the robot that taps the card to flip it, the robot is always tapping the top card. Shouldn't you be tapping the one that is tappable?
I don't remember. I wrote that a while ago. I tried to come up with an example to use both UIKit and SwiftUI, and the card was what I thought of to do that. So I might have gotten that detail screwed up in the test itself, but it seemed logical at the time. So whatever I did at the time seemed like what I wanted to do.
Makes sense. Let's see. We got one more, and then you can take off to Slack to do the rest. Not so much about the code, but about work. Are you dedicated for testing the app, or do you work on the app and have to make sure to carve out time to test as well?
So we one of the reasons we made the switch is that we had a kind of a shift in staffing. A lot of our QA, dedicated QA, was no longer available to write automated UI tests. And so part of the agreement that was with management was that engineering would actually increase the time for the features that we're writing to develop these robots as well. And then the QA testers could be free to actually write the tests and like I showed, just say do this, do this, do this. And since we have those screen robots, it's a very literate way to write a test. So yeah, we're dedicated mostly to writing. All of the developers are writing code and features, and all our QA testers are focused on designing tests and when those tests should be run and running them.
Gotcha. Makes sense. Well, cool. Thank you very much. Thank you for being nimble enough to swap out real quick for us. The lifesaver there. Keep asking questions in Slack. Don is around, and we'll answer them there. And we will be back in just 5 minutes with Nathan. Thank you very much.